Hello and happy belated Mother's Day. Welcome to York Universe, the astronomy and astrophysics podcast written and presented by the students, faculty, alumni, and friends of York University. You'll now find us wherever podcasts are distributed. I'm Paul Mackin, one of your hosts this evening, and I'm joined by my colleague Maheen Hamani. We are both affiliated with the Department of Physics and Astronomy here at York University. Tonight, we are broadcasting live from the Allan Carswell Observatory on the Keele campus in Toronto, Ontario, Canada. York Universe broadcasts live every Monday at 9 p.m. local Toronto time, or currently 1 a.m. Tuesday Universal Time, and we're at the site at York U Observatory. We also run in concert with our online public viewing, or as we call it, the OPV, run by our observatory staff, where, with good skies this evening, they'll be sharing some wonderful live images captured, I think, with our 1-meter telescope and some archival images. And they also answer your questions if you go on to chat on YouTube simultaneously. They'll answer those questions real time. To navigate to our show or to find out more about us, please check out our website at yorku.ca/science/observatory and follow the link to our online public viewing chat on YouTube. Any questions or comments you may have on past shows or suggestions for future topics, please send us an email, or about anything else really, at observe@yorku.ca. You can also always connect with us on Instagram with the handle at Yorku Observatory, or on Facebook at Allan Carswell. All of our programs are free, but if you'd like to make a donation, and we would certainly appreciate that, please see our website at yorku.ca/science/observatory. We will be monitoring the YouTube chat for your questions and post content. So, again, happy Mother's Day belatedly, everyone. It was yesterday. How are you this evening, Maheen? Did you manage to touch base with your mom over the weekend?
Hi, Paul. Hi, everyone. So I'm uh, first day of the week, so no complaints. And as you said, it was Mother's Day this weekend, so it was great to be able to spend some time with my mom, even if it was only over Zoom. And thank her for basically my existence. But yeah, I'm quite excited for this episode. How are you doing today, and how was your Mother's Day?
Yeah, everything's great. Mother's Day was wonderful. We they took my wife, my daughter, and I took my wife to a play to celebrate Mother's Day, and we had a very good time. Um, and I also took time to, think about my own mom, who passed away quite a few years ago. But it was nice to reminisce as well. Um, have you managed to get in? It hasn't. The skies haven't been great lately. Maheen, have you managed to get in any observing?
I kind of got lucky one of the nights. It was right before I think the sky got clouded with black clouds just the past week. I was
Yeah.
able to observe Jupiter and Venus side by side, so that was quite fun. I was very excited because I was able to get it on my phone. It was so clear that night, and I was luckily near dark skies at the time. But yeah, how's observing for you?
Well, I'm looking out my window of my study at home, where I am right now, and about 30 degrees above the horizon. It's a perfectly clear night. I can see Venus. I just have to scrunch down a little bit because it's a bit high. So Venus is up in the sky, and we'll be talking more about the sky at night in a second. I've also got uh, one of my scopes up back cooling. It'll be observing most of the night, and I'll be adding a second one to it right after this broadcast tonight, and hopefully I'll continue with some of the projects I'm working on, which is a great segue for us to go into a bit of a piece on the sky at night. So it's an interesting time in the sky in some ways a bit less going on. We'll talk through that. Right now, as I mentioned, Venus is in the west at sunset. If I look out my window right now, it's about 30 degrees. It's about half an hour after sunset, so that gives you some idea. All you have to do is look for a really bright star in the west after sunset, and I guarantee you it's Venus. And then a bit above it, in the constellation of Gemini, so there's two bright stars, Castor and Pollux, for the Gemini twins. And there's another really even brighter object there, and that is Jupiter. Now it is descending, meaning, back in January, it was in opposition. It was with us all night. So now you've got it probably till about maybe 11 o'clock, 11:30 at night, but it's certainly great to look at. It's quite impressive with the naked eye. And of course, if you look at it through a telescope, you might see some, even a small telescope, you might see some bands in the clouds on Jupiter. And you'll see some of the four, some or all of the four Jovian moons. The moons can actually even be seen with binoculars. Just a good pair of 7 by 35s, or 10 by 50 or 7 by 50 binoculars will do a reasonable job of, you'll see this bright star. You might resolve a disk with binoculars, but you should see four fainter stars near it, or up to four, because sometimes they might be in front of Jupiter or behind Jupiter. But you can see those are the four Galilean moons. Now, in terms of Mars and Saturn, the other planets that we see commonly, Mercury I don't usually list as that because it's so hard to find. But Mars and Saturn are really rising just before sunrise right now. As summer gets going, we are going to see they're going to rise higher in the sky. And Saturn, if you're up early, it'll be a brightish star. Mars will be kind of difficult to spot right now. And my favorite time of year, of course, galaxy season, spring continues. Right now, you can basically see in the constellation of Virgo, there's a whole chain of galaxies. And you can take a look at those. Binoculars will show you some of them, a small telescope as well. It's also, I've noticed of late, some interesting nebula are arising. So there's the owl. I mean, three I'm focused on right now, but there's others. The owl rises early, the dumbbell rises a bit later, and the crescent nebula a bit later still. And again, any website, just look up what can I look at tonight, and if you've got a small telescope, it's very, very much a treat time of year. Even with binoculars, though, the important thing is to get out there and look. And I would start, if you're a beginner at this, start with the planets. But you can also do something called constellation hopping, and an easy way to do that is to start with the Big Dipper. Now, most people can find the Big Dipper, but from where we are in kind of the Canadian area, like in Canada, at night, the Big Dipper is well positioned. If you sort of look to the northwest, it's going to be relatively northwest. It's going to be relatively high in the sky. You'll see the handle of the Big Dipper, and you'll see, if you look a bit, you'll see the bowl of the Big Dipper. Now, everyone knows you can use the bowl of the Big Dipper to find the North Star. That's your first step, which points you to the Little Dipper, because that's the last star in the handle of the Little Dipper. But then from there, you can also use the handle of the Big Dipper, follow the curve, and it'll take you to a bright star rising in the east, and it's a reddish star, and it's Arcturus. You can use the Big Dipper to navigate all around the sky. And again, there's online guides to this, and I think we've run some teletubes on it in the past as well. And it's not the point today to go through all that, but I do want to talk about one thing that's very easy to do with the Big Dipper, and you will need binoculars or a small telescope, but this is and I've got a bit of personal history with this because when I was very young, I went for a walk with my grandfather, and we took a pair of binoculars, and we did what I'm about to tell you, and it probably it was one of the things that set me on the path to where I am now. But if you go out and you look at the Big Dipper, look at the middle star in the handle with a pair of binoculars or a small telescope, and the star is called Mizar. But when you look at it with a small telescope or binoculars, you'll see that it isn't actually one star. It's two stars. It's two stars orbiting each other, and they are called Mizar and Alcor. And again, it's fascinating because you look at it with your naked eye and you see the star, but you look at it with just a bit of magnification, and suddenly it's something very, very different. And that's one of the real treats of astronomy. The more you look and the deeper you look, the more fascinating it becomes. And again, that was one of the contributors to me starting on that on the journey to where I am now. So it's just something to think about. But we're gonna change our topic today. And today, rather than focusing on this week in space history, we're going to focus on mothers in astronomy and space history. And I'd like to start off with a story about the early age of the early years of the space age, where astronauts were expected to kind of fit a very particular image. They were test pilots, usually military veterans, kind of calm under pressure, fearless supermen. And if you actually ever look back through some of the old shows or magazine articles on the Mercury 7, they were all guys, and they were tough, and they were military, and they had crew cuts, and there was definite image. But then in 1978, NASA began selecting women astronauts, but mothers, it was unspoken, but motherhood and spaceflight simply didn't belong together. But in the mid 1980s, one astronaut changed that belief forever. Her name was Anna Lee Fisher. She was a physician, a chemist, and one of the first women ever selected for NASA's astronaut corps. She trained through an era when the space shuttle program was promising to make spaceflight more routine, more accessible. It sort of did and it didn't, but it was definitely ambitious. But then in 1983, her life changed in another profound way. She became a mother. And almost immediately, questions began swirling around her career. Could a mother fly in space? Could she leave behind an infant child to perform one of the most dangerous jobs, not on Earth, but close to Earth? And the criticism wasn't subtle. Newspapers asked whether it was appropriate. Commentators questioned her priorities. This young lady really better think about her baby rather than flying off into space and whatnot. Some openly wondered whether NASA should allow mothers into orbit at all. But Fisher remained determined, and in fact, NASA assigned her to a mission while she was 8.5 months pregnant. Didn't go on the mission; she was assigned then. To her, the issue was never a woman could be both an astronaut and a mother. The answer was obvious. Of course, she should. Then came November 8th, 1984, and in Florida, the Space Shuttle Discovery thundered off the launch pad on mission STS-51A. Inside the spacecraft sat Anna Fisher, who was 35 years old, and she was the mother of a 14-month-old daughter. So for the first time in space history, a mother was leaving Earth for space. And this would not be just a symbolic mission. STS-51A was technically challenging shuttle flight because two communication satellites had failed after reaching orbit, and they were worth a lot of money, and they were stranded and tumbling through space. So NASA decided to do something they'd never done before, capture and retrieve them by hand. During the mission, astronauts maneuvered jet-powered backpacks through space while Discovery carefully approached the disabled satellites one at a time. It was an incredibly precise mission. One wrong move and disastrous, consequences. But Dr. Fisher played a central role in coordinating and operating the retrieval procedures inside the shuttle. Both satellites were successfully recovered and brought back to Earth, which was really a big triumph of engineering, piloting, and ingenuity. But culturally, the mission meant something bigger because millions of people watched the world and saw something new, an astronaut who was also a mother. It wasn't a contradiction, wasn't an exception. She was both. So years later, Fisher reflected on the criticism she received before the mission and noted that nobody had asked fathers in the astronaut corps whether they should leave children behind and fly in space. And the aforementioned Mercury 7 astronauts were all fathers. And if ever you've seen the movie First Man with Ryan Gosling about the Apollo 11 mission, that actually plays a big part of his story, leaving behind two young boys after he'd already lost a child. and his family coping with this while he went on an extraordinarily dangerous mission, and that was considered acceptable. And it was, of course, it had to become considered acceptable for mothers as well. Um, so Dr. Fisher permanently changed expectations, not only within NASA, routinely, women with children routinely serve upon the ISS, command spacecraft, conduct spacewalks, and so on. And, they're going to be significantly involved, because all humans are, with lunar and Martian exploration. But somebody had to be first, and someone had to prove that exploration and motherhood could coexist. So this week, as we celebrate Mother's Day, we remember that historic moment in 1984 when Anna Fisher helped redefine who gets to explore the cosmos, not despite being a mother, but just while being one.
Um, I, this was a very interesting story. I find it quite commendable that someone, at a time when women aren't meant to be these things, she was a physician, she was a chemist, and then she became an astronaut, and then she was also a mother who was criticized for leaving behind her child to go into space. And despite all of those psychological barriers, and then, of course, like being a physician or a chemist or an astronaut itself is not easy. That all requires so much effort and work. And still being able to persist and do everything when basically everyone is kind of against you in that is very commendable. And it really makes me sad that people have to like fight for things that are so basic. But I'm still glad that she was able to persist and create this good example for people coming in the future so that they wouldn't feel discouraged if they wanted to do the same thing.
Yeah, it's true. I mean, someone's always got to be first at everything. And Dr. Fisher was the first at that. Sally Ride was the first American woman in space, and there were Soviet female cosmonauts as well. But you also have a story for us about another woman heavily involved in astronomy. And so I'll turn that over to you to talk about that.
Yes, I do. Thanks, Paul. So my story is slightly different. So for this week of Mothers in Space slash Astronomy History, I say this week because it coincidentally also happens to be that this event happened in this month, in this week. So I want to start us off with a woman who wasn't a mother in a traditional sense, but who dedicated her life to astronomy at a time when women were not supposed to be scientists, which eventually led her to be called the Mother of Hubble, the unfolding of which I will be discussing. So, Dr. Nancy Grace Roman was a woman in science who faced discouragement, skepticism, and rejection throughout her career as an astronomer, beginning at a very young age. Her birthday is this week since she was born on May 16th, 1925, to a geophysicist father and a music teacher mother. Her mother often took her out for nature walks to observe the birds and the trees, but what captured her attention the most were the constellations in the night sky. From this interest in her very early stages, by sixth grade, she started an astronomy club with friends, and a year later, she knew that she wanted to dedicate her life to the cause of understanding the universe. And despite being questioned by a high school counselor about taking an algebra class over Latin as a girl, and generally receiving opposition about her career aspirations and choices, she went on and completed her bachelor's degree in astronomy from Swarthmore College in 1946 and her doctorate in astronomy in 1949 from the University of Chicago. After her PhD, she continued teaching and researching stars at the university-operated Aircase Observatory at the same institution that she got her PhD from. At this time, however, she realized that no matter the level of seniority, no women in her department had received tenure, which created concerns regarding her career aspirations in academia, because she knew that there was only one tenured woman in astronomy in the entire country at the time, and so the chances of that happening were extremely low. This made her accept a position in radio astronomy at the Naval Research Laboratory instead of pursuing academia. In 1959, when NASA was only a few months old, an employee had asked her if she knew of someone interested in creating a space-based astronomy program in which she herself expressed interest, and this ended up in her being hired by NASA. And even though by this time she had almost 6 years of work experience since her PhD, none of it was officially considered due to how underpaid she was. So this was the state of things at that time. And despite all this, by 1960, Dr. Roman was the chief of astronomy for NASA. She was the first chief of astronomy and also the first female in an executive role at NASA. This shift from working in academia to working for the government proved fruitful for not only Dr. Roman, but also all astronomers and the public who have been able to reap the benefits of the work she had started. Since she was involved with securing and administering grant funding for different NASA missions and understood the scientists she interacted with because she herself was an astronomer, and the needs of the field of astronomy, she soon realized how unavoidable the need for a space-based telescope had become. And this is when she devoted herself to securing approval and funding for the Hubble Space Telescope, the very first space telescope, the images of which, many of us have seen growing up. Um, and has inspired our interest in space and astronomy even more so than just looking at the night sky. So it almost took 20 years since she started at NASA to gain approval for the Hubble telescope, and that's a long time, um, which marked the beginning of a new era in the history of astronomy once it was approved. So, apart from understanding and relaying the importance of placing a telescope above the Earth's atmosphere, which we all know it allows us access to a greater range of wavelengths, it protects us from light distortions and atmospheric distortions. So, we really needed a space-based telescope at that time, and she relayed the importance of it. She also ensured that there was inclusion of imaging sensors called charged coupled devices or CCDs on Hubble instead of previously used standard sensors. And although this was risky at the time because CCDs were still being tested, they went on to become the new gold standard for astronomical imaging and now are widely used in telescopes. So she was constantly in touch with scientists, ensuring the alignment of scientific objectives and the mission design. Her dedication to Hubble led her colleague Ed Wheeler, the future Hubble chief scientist, to name her the mother of Hubble. And in this way, she became a pioneer in the materialization of space-based astronomy, along with the physicist Lyman Spitzer, who was also an advocate of a observatory for decades at the time. And so they are often mentioned together. Roman passed away in December 2018 at the age of 93, but she was, of course, not forgotten. In 2020, 15 months after her passing, NASA named their next generation of space telescope in her honor and called it the Nancy Grace Roman Space Telescope. This telescope is scheduled to launch as early as September 2026, which is this year and in a few months, and no later than May 2027, depending on how things go with the launch. The mission will explore questions regarding dark energy, exoplanets, and infrared astrophysics, and will generate approximately 20 petabytes, which is equivalent to 20,000 terabytes of infrared survey data over its 5-year mission, which in itself is mind-boggling and exciting for astronomy because that is a lot of data and it's over a wide range of sky, so we're going to get a lot of information. And in this way, through her unprecedented efforts towards Hubble, Dr. Roman made her way in our Mother's Day special episode as Hubble's mother and will always be remembered for the role she has played in space-based astronomy.
That's great. And yeah, the mission is it has a launch. a launch schedule now. I believe it's going up on I think it's on a Falcon Heavy in September. And I mean, that date can always slip, of course. And it will be flying out to the L2 point, Lagrange 2 point, where it'll be in the great company of James Webb. And a few other there's a few other missions out there as well. Um, the amount of data bringing back is incredibly uh, incredible. And the thing about that telescope is that it is basically kind of a Hubble on steroids. It's got the same resolving power, same size mirror as the Hubble Space Telescope, but it's got, I don't know, 20 times the field of view. And the amount of data coming back, and we're going to come back to this concept of data because it's becoming increasingly important. But the amount of data that's being collected is amazing, and I think it's so fitting that she get called the mother of Hubble, uh, and that NASA has honored her. And going back to the time, and she joined NASA the year I was born. Uh, it was a very different world then, and NASA was an organization that didn't. They had a real clear mission to get someone on the moon pretty quickly. They took their science seriously, and had a tendency to push aside a lot of the more conservative social norms. And if anyone's ever seen the movie, oh God, what's it called? The one about the computers at NASA. The name slipped my mind, but they, they were becoming increasingly integrated with minorities, and it's it's a bit of history we should all take inspiration with. So I'm fully in favor of suggesting that this is an appropriate posting for a Mother's Day, and I want to thank you for covering it today. I mean, that's just it's a great story.
Yeah, and it just makes me happy to hear that NASA, even at that time, was going against, the social norms, as you said. And it's great to hear about your, first person experiences of like things that I read. So yeah, thank you for sharing that.
Yeah, it's it's just we are living in a very different world than the world she experienced. And I guess because I'm a bit older, I sort of saw both. And the movie I was mentioning, I just quickly looked it up. It was Hidden Figures. It came out a few years ago in 2016. And I remember taking my daughter to seeing it. And it's interesting because I don't know if she was inspired by the space aspect of it, but she's been very good at math. And she's also planning on studying math next year at York, which poor girl is going to have to go to school with her dad, which is shocking, but kind of funny. Anyway, we're at the halfway point, and I'd like to take a minute to do a couple of reminders. You are listening to York Universe, the space and astronomy podcast from York University. We are broadcasting live from the Allan I. Carswell Observatory at York's Keele campus in Toronto, Ontario, Canada. Please look at our website, yorku.ca/science/observatory. Follow the link to the online public viewing, and you can join in the chat if you have any questions or want to see some of our content. I haven't seen any live images come up yet, but if they do, we'll make a point of trying to shout them out. And you are listening to Paul Mackin and Maheen Mahoney. Now, I'd like to also mention that we're having regular observatory tours throughout the summer. And this week it will be our regular tour, which means you come up to the observatory, you get a tour of the 60 centimeter, you get a tour of the 1 meter, the control room, you get to hear about what we do. And, we're going to be conducting that throughout the summer. And we do ask you to get a ticket. You don't have to pay for it; it's free. But just to control, the numbers and schedule people, because it's a relatively limited space in an active observatory. So we ask you to go to our website for a free ticket. Um, I'd also like to take a minute and talk about something that's coming. It's not really coming that quickly. It's we're talking late August, but we're going to be plugging it all summer. We ran it last year, which is our Astro Fair. Um, Tickets are $30. It's a day long and evening long event, and the proceeds from that goes to funding our observatory. And I believe I'm seeing an image starting to come up on the screen now. I'm not quite sure what it is, but we'll get there in a second. And uh, this is a great day of fun. So just go to our website and you can check it out. And we'd encourage you to come. I think you'll meet a lot of the people that do this podcast. I'll be there, and I imagine others will as well. So, please consider coming. It's a great way to spend a day late in August. Did you go last year, Maheen?
I did not, but I am planning to attend this year, so I'm excited for that. How was it
That's
last year?
I missed it. I was actually out of the country,
Oh,
but it sounds like it was a lot of fun. So I think again, I think they're trying to get something up on the screen. It's a little hard in the YouTube chat. I'm trying to see what it is. They're moving it, and I can't really tell. And
there
if
it's
anyone
Venus.
is it? Oh, is it Venus?
Yes.
It is. Oh, that makes sense. Yeah. Okay. It is Venus, and it looks like pretty it's still pretty small, but it looks like it's a nearly or very close to full phase. And of course, the closer to the sun it gets, the more likely that is to be. So there's a live shot of Venus on the telescope right now on our YouTube chat. Okay, so to news, Maheen, you've got some information about dark galaxy candidates.
Yes, I do. So I will start us off with our space news section today. So I'm going to be talking about 70 dark galaxy candidates that were found in the FAST survey. So contrary to what many people think, galaxies are not always radiant with stars. Sometimes galaxies are only rich in gas and dark matter, with very few or no stars. And these things are called dark galaxies. They are difficult to detect due to their lack of stars and visible matter. I shouldn't say visible matter because gases count as visible matter, so maybe you can just say they're difficult to detect due to their lack of stars mainly. Recently, astronomers have identified 70 potential dark galaxies using early data from a Chinese radio telescope called the 500-meter Aperture Spherical Telescope, or FAST for short. And dark galaxies have been predicted theoretically for a long time. So, our current cosmological model, or I should say the widely accepted cosmological model, which is called lambda CDM, describes the clumping of dark matter halos into halos across a wide range of masses. And these include halos that are far lower in mass than what we actually observe as galaxies. And it has been suspected that the cause of no star formation within these halos had to do with gas heating within them, due to quasars and early universe galaxies, which were very hot, or that they were simply too small to gravitationally sustain the cold gas needed to create stars. Because as you might know, that stars require a very specific temperature of gas so that it would collapse and form stars. And in search of dark galaxy candidates, a team of astrophysicists led by Marco Monacchi at the Center for Astrophysics and Supercomputing at Swinburne University of Technology scanned the sky for neutral hydrogen gas emission, which neutral hydrogen emits a very specific radio signal at a wavelength of 21 centimeter, and this is famously known as the 21 centimeter line. So when it is detected, we can kind of go to the conclusion that there is neutral hydrogen in that area of the sky that we are observing. And it is a line which is produced from a spin flip of the electron in a hydrogen atom. Since such detection can also point to gas clouds trapped in interstellar medium due to galaxy interactions, they ensured what they were observing was isolated, so it wasn't due to galaxy interactions. Um, and they also ensured that they had no optical counterparts in other surveys through comparison, which I'm going to talk a little bit about as I continue. So in the FAST All Sky H1 survey, which is just the numeral one has to do with neutral hydrogen. They started with 41,741 neutral hydrogen sources, which was narrowed down to 3,436 sources within 50 million parsecs of Earth. So there was a distance limit that they set to kind of only include a specific number of galaxies that can be trusted to be dark galaxies, which were then cross-checked against major optical galaxy catalogs to filter out known galaxies that have already been covered in other surveys and have been ensured as being normal galaxies, not dark galaxies. And at the end of this check, they had about 1,278 sources with no optical counterparts, which then again they did further checks, which led to another cut and remained 1,091 unknown sources. And then they also did further analyses and removed sources with bright galaxies nearby because they could have an influence on the observance of the dark galaxy. Um, and so they could be likely optical counterparts, or if they were difficult to determine, those types of sources were removed. And at the end of all of this, so there were, as you heard, there were a couple of cuts that they did uh, using different conditions and different requirements to be sure that what they were calling dark galaxy candidates can be called dark galaxy candidates. They ended up with 70 dark galaxy candidates, which may contain almost dark and dark galaxies, meaning galaxies with either no stars or with stars that are too faint to detect with current optical surveys. So for now, these galaxies have been identified as the best candidates, and further and deeper inspections are still necessary for confirmation. However, such observed confirmations and quantification of dark galaxies can serve instrumental in confirming or refuting our current cosmological theories and therefore improve our understanding of the universe's creation and its composition. So even though it's quite a tedious process, doing this can be very useful so that we can determine the composition of the types of different galaxies, because if we're able to do that, we can improve our cosmological model and therefore improve our understanding of the universe as a whole.
That's fascinating. Now, with these galaxies, the dark galaxies, is the idea that they are dark? They are primarily dark matter, or they could be regular baryonic matter, just not sufficient amounts of neutral hydrogen to form stars. What's the thought there?
So there is baryonic matter because there is gases. And there is neutral hydrogen. So neutral hydrogen is characteristic to dark galaxies because it is just a gas that is not collapsing or forming stars. Because if galaxies have stars in them, the hydrogen is usually not neutral because of the heat, right? So
Right.
it's not no longer neutral. So it's characteristic to dark galaxies. So there is baryonic matter. But it's just that there's no star formation because
Got
of
it.
either very small size or there not being enough ability for the galaxy to form stars. So they're just like dark matter plus baryonic matter, but no stars.
That's amazing. That's amazing. It's a great story. I just want to take a side and say, anyone watching our YouTube feed, there is a great image of Jupiter up on the screen right now, captured with our 1 meter. It is gorgeous. You can see the equatorial bands really nicely. Can't see the moons, but that or maybe one. No, it's That's a spot on my screen. You can't see the moons, but you can see the equatorial bands. And of course, if they had to, with the 1 meter, if they were to show the moons, you'd basically saturate Jupiter out, and it wouldn't really be as pleasant to look at as it is now. So it is just a lovely image. If anyone wants to take a minute and take a look at our live feed, which shows also the software we use for the telescope and so on. So it's certainly worth looking at. Anyway, that was a great story. Thank you. Thank you very much, Maheen. But, going back to your story about Nancy Roman, one of the things that we talked about was the amount of data being generated by our instruments. And we talked about, 20 petabytes. That's a lot of data. That's 20,000 terabytes. And my computer at home came with 1 terabyte, and I added some more external drives. But that's it. It's equivalent to 20,000 of those computers in terms of storage. It's just a colossal amount of storage. Another telescope that we've talked about here, Vera Rubin, they're producing 1 to 2 terabytes a day. And they've got a 10-year mission, so 365, call it 500 terabytes a year. Also kind of, over a 10-year mission. That's 5,000, that's 5 petabytes over the life of its mission, primary mission. I'm just doing that math off the top of my head. And this is becoming both a challenge because we have to store this, and it's also a challenge because what do you do with it? You don't really know what you've got. And so our next story here talks about looking at the data, which is growing exponentially, and figuring out how to mine it for information to get new unexpected information out of these data caches. And that's becoming its own thing. An example was reported last month in the Astrophysics Journal. Using NASA data and machine learning, AI, scientists have found over 10,000 possible new exoplanets in a single survey. Now, this is really significant because in this new study, researchers used machine learning to perform a sweeping survey of data from NASA's exoplanet hunting, transiting exoplanet survey satellite TESS. And as a result, they recovered exactly 10,091 candidate planets that had never been seen before. So, these are planets beyond our solar system. They're known as exoplanets, and they're considered candidates until they can be confirmed with the right amount of evidence, usually some follow-up, some independent observing, and verification. Some of these candidates might not end up being planets at all. They could just be noise in the data. But with that number, there will be some. Now, we've captured about 6,200 confirmed exoplanets, according to NASA's Exoplanet Archive. But if we start to introduce significant numbers from this bunch of candidates, we'll be adding a ton of new worlds to the mix. It's a major haul of exoplanet candidates. And but it does beg the question, why haven't they been seen before? TESS has been operational since 2018 and is on an extended mission, so it's always gathering new data. TESS is operated by capturing transiting planets. So what this is, and this is something students at York in the astronomy program get to do in their third year. You take data and you look for little light curves. So as a big planet goes in front of the right kind of star, it will at the right angle, it's sort of in a plane with where we're observing from, you will see a very slight dimming of the light from that star. It's a transit curve. So it's kind of edge on. You have to see it edge on, but you can see this star dim, and TESS can measure that dimming, therefore revealing information about the planet in front of it. And really sophisticated techniques can even infer something about atmospheres around those planets and so on. And planets orbiting brighter stars are easier to spot, and big planets compared to the size of their star are relatively easier to find rather than small planets. And most of the planets found this way are they're kind of often called hot Jupiters, which means they are very large planets very close to their star. Um, However, this new study pulled data from further stars. The actual survey looked at stars 16 times fainter than those targeted by TESS. And using, again, machine learning, the team surveyed over 83 million stars that were observed during TESS's first year of observations. TESS looked at just big chunks of sky. Of these many million faint stars, TESS looked at 10,091 appeared to be transiting planet-like objects never seen before. And again, they might not be planets. It could be just noise, but the research team wants to start further testing to confirm these results. And in doing so, they were able to confirm one of the candidates, a planet called, I love these names, TIC 183374187b. Just that name just makes my heart go pitter patter. This world appears to be a hot Jupiter, which is a kind of a gas giant close, very to its star, which is very close to its star, which is why it's hot and has a similar mass to Jupiter. But besides confirming all these exoplanets spotted with this research, the team is going to try and take this one step further. Well, this study used the first year of test data. The research team aims a follow up using test's second year of data. Okay, and the lead author was someone named Jonathan Roth, a graduate researcher at Princeton University, says in the article. Um, this is a boom in exoplanet discovery. And it comes 30 years since the first exoplanet was confirmed, 51 Pegasi b. It was founded in 1995. With that confirmation, scientists were able to definitively say they had a candidate, like a real exoplanet. Now, they believed that to be the case for years. Um, the planet, it just seemed almost common sense that planets must exist around other stars in the solar system than outside of our solar system. And in fact, some scientists believe that every star likely has planets. And that may not be totally true, but I would say the current consensus is most stars have planets. Since then, NASA missions like TESS and Kepler have provided data that's grown the field tremendously. Webb is doing that as well. And as mentioned, one of the things that we talked about earlier in this broadcast, Nancy Grace Roman Telescope, launching this year, will be carrying a chronograph which is specifically designed to find planets around other stars. So, looking to the future, we're going to see a lot more of this. It will show us more exoplanets, but it will also allow for we also have opportunities for more in-depth study of these worlds and their atmospheres. Uh, so, you know, we've also got another observatory which is being built now called the Habitable Worlds Observatory, which is designed to look for habitable worlds, planets like Earth. So this is a very rapidly growing field, and I think just it's a bit like drinking from the fire hose, but the data is there, and we're capturing it all, we're keeping it all, and we're starting to mine it. Maheen?
Yes, it's crazy how we've gone from believing that the Earth is at the center of the universe to now discovering a billion other planets just in our own Milky Way and more to come. I
It's
find that quite fascinating.
every time we think the Earth is special, we find out that it's not. So,
Yes, unfortunately.
well, I mean, it's nice to understand. It's nice to understand the universe as it is, I think. But speaking of planets, though, you've got something about Mars.
Yes, I do. So, I have an interesting story, or at least I found it interesting when I heard about this. And this has to do with the Curiosity rover that was sent to Mars. So this is rather unexpected, and as some of you listening may know, the Curiosity rover, part of NASA's Mars Science Laboratory mission, was launched in 2011 and was the largest and most capable rover sent to Mars at that time specifically. Now we know it's Perseverance, which was sent in 2020, but at that time it was the largest and the most capable. And its goal was to answer the question of whether Mars ever had the right environmental conditions to have supported small life forms called microbes. Um, and it has since continued to explore the rock record from a time when Mars could have sustained microbial life. And although Curiosity has so far done amazing in terms of combating Mars's intense radiation, extremely low temperatures, and dust storms, something happened last month in April that was unexpected. So on April 25th, Curiosity drilled into a Mars rock, which was nicknamed Atacama, and accidentally yanked the entire thing out of the surface. And during sampling, it did not cleanly break apart from its drill, and instead it remained attached to the rover's drill sleeve as it lifted its robotic arm away from the surface. From current estimates, it seems that Atacama was actually a big rock, so it was measuring about 1.5 feet at its base and about 6 inches, weighing about 28.6 pounds, which made matters worse because of how big and heavy it was. And this was one of the first for the Curiosity rover in over 13 years on Mars. And so it took some troubleshooting by NASA engineers to free the Curiosity rover from this stuck rock. For some context, this was the first of the 42nd hole Curiosity had drilled in 13 years that ended up this way, suggesting how rare such a mishap really is. And so the first thing they naturally tried was vibrating the rover's drill to shake the rock loose, but that didn't do much to help. 4 days later, they tried vibrations again after reorienting the arm, and that shed just some sand, but again did not remove the rock. And on May 1st, they reapproached this method and tilted the drill more, rotated it, vibrated it, and then spun it around until finally Atacama let the rover go. So the rock broke apart as it hit the Martian surface. And the good news is that not only is Curiosity now free again, but it was also not damaged from this incident, which could have been a concern, but we're good there. And so this means it has now returned to its normal operations of Mars exploration. But it was quite interesting because there's a lot of GIFs that are surrounding the internet of the rover doing that, and it's actually quite funny. But yeah.
Yeah, I don't know what it is about the story that's just charming. It makes me smile. It drilling a hole in the rock and then pulls the drill back, and the rock comes with it, and it's stuck with it for days. And it's trying to shake it off. It's just, it reminds me of someone getting fly paper on themselves or something sticky on themselves, and they grab it with their hand, and maybe they step on some tape, and then they try to pull it off, and then the tape stuck to their hand, and they pull it with their other hand, and it's now stuck to that hand. How do you get rid of it? It has that kind of image to it. It's delightful. It's a great story. But the good news, of course, is that it's all good. It'll go on. It'll go on to drill another day. I just adore this story. I've often said that Mars is about one of the least interesting objects you can look at through a telescope, but boy, it's a great place to send a spacecraft. It really is. It's incredible. So yeah, thank you for sharing this. It's a very sweet story. Um, our last item for today is got to do with SpaceX, which is targeting this Friday, May 15th, for the launch of Starship Mission 12. So, to recap, there have now been 12 Starship launches or 11 Starship launches. These are test missions. They don't do anything other than go up and come down. But they test a whole bunch of technologies, and this is really important technology because the Starship itself is really very likely the lunar lander for Artemis 4. It's got to get up there and be able to function and do a whole bunch of other things. But so far, this is still a test program. But this is a new version of the rocket, it has twice the payload of previous versions. The new version of the Starship V3 is described as fundamentally more capable vehicle than the V2 variant that flew earlier test missions. The differences are substantial and span nearly every major system. The most visible change is size. The V3 stretches out with longer propellant tanks, and at 125 meters, the full V3 stack is taller than the Statue of Liberty from base to torch tip. It's huge. Then underneath the fairing, the Super Heavy booster will fly with uh, 33 Raptor 3 engines, which replaced the Raptor 2 engines used on previous flights. Raptor 3 is a redesigned engine with higher thrust, improved efficiency, and it's a simplified architecture. And actually, if you go online and take a look at Raptor 2 and Raptor 3 engines, it just looks simpler. It's got not less a lot less piping on it. And if you go back and look at the Raptor V1, you can see how far they've come. But SpaceX says that the engine delivers roughly 20% more thrust than its predecessor, which means it can get heavier payloads into orbit. And it's also simplified in such a way to reduce the manufacturing costs and the turnaround time, because these are reusable spacecraft and engines. The payload target is where V3's ambition becomes clearest. SpaceX has said that the V3 aims to get over 200 metric tons in low Earth orbit once it's fully reusable. By comparison, the most any previous Starship has carried is a fraction of that figure, and even the V2 targets were only 100 to 150 metric tons. The tripling the payload framing reflects the gap between what the earlier test flights actually lifted. So they could, in theory, lift 100 to 150 metric tons, but they didn't. And then it's compared to what the V3 is engineered to deliver. The V3 planned flight profile, the flight profile for Starship 12 is expected to closely follow the established Starship flight architecture. But again, noting these are test missions. So with modifications to test the V3 specific capabilities, and based on what we know of the Federal Aviation Administration permit filings and some publicly available information, the expected sequences lift off from Launch Pad 2. And that's a new one there, because right now they had one launch pad at Sarasota, which is where these launch from in Texas. So this is a new launch mount, and it's designed to validate that new launch system before it goes into full production. There'll be hot stage separation. So what this means is that the Super Heavy booster engines, the Starship engines light while it's still attached to the Super Heavy first stage. And then they separate using compressed gas, which gives an additional force. And this was an innovation for Flight 3. And there's actually a ring attached to the the lower stage to allow the gases to escape. They are planning on doing a booster return and catch, which they haven't done in a while, but they have successfully done in the past. So the Super Heavy performs a boost back burn, reentry burn, and landing burn, and then giant chopstick handles at launch pad 2 will grab it and hold it. The Starship itself, rather than the Super Heavy, will go into orbit. It will do It will fire its three Raptor engines to achieve a low Earth orbit trajectory. Now, it isn't a really proper orbit. It would decay on its own, but they want to test, can they get the necessary velocity to do a full orbit? And then they will do a payload demonstration. So it's going to expected to carry a simulated payload of mass simulators. And these are probably, they haven't said this, Starlink satellite simulators. They're not Starlink satellites, but they're kind of boxes that look like that, and they eject a bunch of them to see that they can do that. And then the Starship, will re-enter and landing. It performs a controlled re-entry of the Indian Ocean, and then does a propulsive water landing. So it puts itself upright, and then it will land. Now, if there is confidence, there's some talk that if there's confidence they can do it, they might try to bring it back to Starbase for a tower catch. Frankly, I don't think that will happen. So, and this is all subject to change. The launch date is subject to change, and the actual flight profile is subject to change. And it can change on weather, range availability, what they feel the hardware is capable of, their confidence level. But the targeting of this month is consistent with the pace of the V3 hardware preparation, of which can be seen at Starbase. So there are live feeds from Starbase showing them stacking and testing the hardware and doing loading propellant and then clamping down the rockets and firing the engines and so on. So that's all available there. So, it's exciting, but, we're now at time. So I'm going to quickly do some closing remarks. First of all, I want to thank my friend Maheen for contributing tonight. And I want to thank you for joining us. You've been listening to York Universe, the astronomy and astrophysics podcast, written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Maheen Hamami and me, Paul Mackin. The podcasts and past episodes are available wherever podcasts are distributed. You can always connect with us on Instagram at YorkU Observatory or on Facebook at Allan I Carswell Obs. Our website is yorku.ca/science/observatory. There's a lot of interesting free content there. And if you feel so inclined, it's a great place to make a Canadian tax-deductible donation to help us run our student-operated, not-for-profit observatory. Thanks for tuning in this evening. Have a great evening. Again, belated Happy Mother's Day. Clear skies, everybody.
Clear skies.